All right, in this video, we're going to look at how to write the standard equation of an ellipse by given various kinds of information. Here in this first problem, we're given the equation of an ellipse. It's written in general conic form. So basically, everything's fully expanded. How do I know it's an ellipse? Well, I know that I have y and x are both being squared. Now, I technically don't know it's an ellipse until I start the process of trying to put it in standard form, which would be I would move everything that has a variable, x or y, onto one side and the constant onto the other. So what I'm going to do is I'm going to move all of my x's and y's to the left, move the constant of 25 to the right-hand side, and I'm going to rewrite. And when I do that, I wind up having x squared plus 10x. I'm going to leave myself a little bit of room. You'll see why in a minute. Plus 100y squared plus 200y, leave myself a little room, is equal to negative 25. Now, I want to go through the process, and I want to complete the square. The reason is because I'm trying to write in standard form. Now, I now know it's an ellipse because I have x squared and y being squared, and they're going to be adding together by the time I'm all said and done. Now, I know that's a negative right now, but by the time I go through and complete the square, I'm going to wind up having a positive number over here. So I want to write this as x plus a number being squared times, so I want to write this as x minus h squared over a squared plus y minus k squared over some number being squared is equal to 1. Now, which number has the bigger denominator? We don't necessarily know at the moment, but we will find out here at the end. I need to make the coefficient of y become a 1. Now, I can't just divide everything by 100, because then it's going to give me a coefficient of 1 over 100 for this x squared. So I'm going to have to kind of work around that. So I'm going to have x squared plus 10x, and then I got plus. I'm going to factor out 100. So I'd have 100 times y squared plus 2y, leave myself a little bit of room here, is equal to negative 25. So I'm going to come here and I'm going to pre-make my next line, so that way I can show my factors being squared. So I'm going to have x and then something being squared, and I still got plus 100 times, and then I'm going to have a y factor being squared and equals something. Now, what I'm going to do is you take the number in front of the non-squared term, you divide it by 2, and you bring it down here, so that'd make x plus 5. Now, I square this number, and I put it back in the previous line, and that means that that binomial is going to create a value of adding positive 25 on the left. Now, I put a plus 25 on the left, I have to put that same value over here on the right-hand side to maintain balance. And then we're going to do the same thing for the y term. So I need to half the non-squared term for y, so that makes y plus 1. Square that, that makes plus 1 here. Now, my offset to the left side is I just put a value of 100 times 1. Now, I need to put 100 times 1 on the right-hand side, which is 100. And I add all this together, and I get a right-hand side of 100. Now, to put it in the form, the standard equation of ellipse, I need to have this right number become a 1. So I can divide everything by 100. So I divide all pieces by 100. And we get our standard form of this ellipse to be x plus 5 being squared, divided by 100, plus y plus 1 being squared is equal to 1. So I want to write an equation of this ellipse. Now, looking at it, the ellipse is elongated vertically. So the standard equation for this is we're going to have x minus h being squared plus y minus k being squared is equal to 1. Since it's elongated vertically, y is going to get the bigger denominator, which I'm going to call a squared, and x is going to get the smaller denominator, which I'm going to call b squared. So I'd start by trying to find the center. Well, you can find the center by first finding the vertices and the co-vertices. So my vertices are identified. I have identified here is the tallest and the lowest points where it's stretched, and I'm going to draw a line that connects them. And then I'm going to look for my farthest right and farthest left values for where it's like stretched out here. And looking, I have a value there at what x value of 2, y value negative 1, and then right there at negative 4, put 2 dots there. Those are my co-vertices. And I'm going to draw a line that connects them. Where those two lines intersect is my center. So I have a center at negative 1 comma negative 1. That gives me h and k. Now, A is the A is the distance from the center to a vertex. And so A is going to be, well, we have 1, 2, 3, 4, 5, 6. So A is going to equal 6. B is the distance from the center to a covertex. So 1, 2, 3. So B is equal to 3. And so now we just plug everything in. And so our equation for this ellipse will be x plus 1 being squared divided by 9 plus y minus negative 1, or y plus 1 squared, over 36 is equal to 1. All right, next problem here. So we're given two vertices and the location of two foci. And so I'm going to make a rough sketch to see what it is I'm looking at. So my vertices are 2, 4, and 2, negative 22. So my vertices are oriented vertically. If my vertices are stacked up and down, that means my general equation is going to be x minus h squared plus y minus k being squared is equal to 1. And the orientation is going to be vertical, so y is going to get the bigger denominator and x is going to get the smaller one, because your orientation is in the direction of your two vertices. Now x here locates my center is going to be halfway in between those two vertices. So the coordinate of my center is going to share the coordinate, the x value of my vertices of 2. Now I got to find the middle y number between 4 and negative 22. And that's going to be the location of my center, which is going to give me a middle y number. You can always just average the y. So 4 plus negative 22 is negative 18. Divided by 2 gives me negative 9. So there's my center for h and k. The distance from my center to a vertex is going to give me a. And so how far away is negative 9 from negative 22 or from positive 4? And so a is actually 13. And so we know A, we know H and K. All that's left is to find B. Well, we're not given any information about a covertex, but we are told the location of a focus. The focus is, the distance the focus is from the center is C. So to go from negative 9 to negative 21, C is going to be 12. And so we have to solve for B. The Pythagorean relation for an ellipse is a squared is equal to b squared plus c squared. So 13 squared is equal to b squared plus 12 squared. And so you wind up getting 25 is equal to b squared. I'm not actually going to solve for b because all I need to know is b being squared. And so we put everything into our equation. We have x minus 2 squared over b squared, so over 25, plus y minus k squared, so y minus negative 9, y plus 9 squared, over a squared, 169. Is equal to 1. All right, new problem. This time we're given the two foci and covertices, and we want to write the standard equation. Well, looking at this problem, I'll start by making some points. So we got our foci are located left and right of each other. All right, and the covertices are located up and down from each other. The center is going to be right smack in the middle between the foci and the covertices. So looking at what we have, now the foci share the y value of negative 1, so my center is going to have a y value of negative 1. Covertices share the x value of 10, so my center should have an x value of 10. So our center is at 10, negative 1. We get h and k. Well, the distance from the center to a covertex is b. And so the distance from the center, which has a y value of negative 1, to a covertex of has a y value of 3 or negative 5, tells me that b is going to be 4. Now, the distance from the center to a focus is c, which means that the distance from the center that has an x value of 10 to a focus that has an x value of 13 means that c is going to be equal to 3. Now, I got to figure out the orientation. Well, if my foci lie left and right of the center, that means the vertices are also going to be left and right of the center, which means that we're going to be elongated along the horizontal, which tells me that x is going to get the bigger denominator when you compare that to the x and the y parts in our standard form. So we can go ahead and write a general form so that way we can see where to plug in our numbers. So I got to still solve for a. And I'm going to have to use the Pythagorean relation, which is a squared is equal to b squared plus c squared. Well, a squared is really what we want to know. We know b is 4. and we know c is 3. And so a squared is equal to 4 squared plus 3 squared, so a squared is going to equal to 25. A would equal 5. Now we plug everything in. So our general form, or our standard equation, is going to be x minus h squared, so x minus 10 squared, over a squared, 25, plus y minus negative 1, y plus 1 squared, over b squared, which is 16, is equal to 1. There's our standard equation. All right, next problem. Here we're given an eccentricity ratio of c to a as being 4/5. I know this is an ellipse because the eccentricity is smaller than 1. So since the eccentricity is smaller than 1, it's going to be the ellipse. I got to figure out my orientation. Well, let's look at the foci that are given. The foci are located vertically of one another. So if my foci are vertically, my orientation has to be up and down, which means that y is going to get the bigger denominator. So we'd have x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And now we start finding out information. Well, we go find our center. The center is going to be in between the two foci. Then that's going to be at 0, 8. And so we have h and k. Now we need to find out our constants. Well, looking at the information we have, the distance from the center to the focus is c, which the distance from the center to a focus winds up being 4. Now, how does that help us? Well, we can go use our eccentricity. If we know c is 4, we can solve for a. So eccentricity is 4 over 5. Well, we know that c was 4, which means that a has to be 5. So we got a to be 5. And so all we need left to do is to find b. Well, we use the Pythagorean relation. A squared is equal to b squared plus c squared. So a squared, 25, is equal to b squared plus c squared, 16. And we wind up getting b squared is going to equal 9. So b would equal 3. We put everything in. So our equation here would be x minus 0 squared, just write x squared, divided by b squared, so over 9, plus y minus k squared, so y minus 8 squared, over a squared. Well, we said a was 5, so that's going to have a denominator of 25, is equal to 1. There's our standard form. One more example here. This time we're given an ellipse that has an eccentricity of 5 over 13. I know it's an ellipse because the eccentricity is less than 1. So eccentricity is the ratio of c to a. Now, my co-vertices we're given. We have a x value of 3 and a y value of 18, and an x value of 3 and a y value of negative 6. So my co-vertices are up and down, which means that my actual vertices are going to be left and right. So we're going to be elongated along the horizontal. Now that means that x is going to have the bigger denominator when you're looking at the standard form. And so we'll go ahead and write a standard form so that way we can see where our constants go. And we need to first find our center. Well, the center is going to be right in between the two co-vertices. So we'd have an x value of 3. And now the y value, 18, we just average the y. So 18 plus negative 6 gives me 12, divided by 2 gives me 6. So my center would be at 3, 6, which gives me h and k. Now I need to work my way, and I need to figure out what a and b are. Well, the distance from the center to the co-vertex is b. Now we know where the center is, and we know where the co-vertex is, so b is going to wind up being 12. And so we know that b is 12. Now we got to work our way to figure out, well, what is going to be a, so that way we can write our other denominator. Well, the ratio of c to a is 5 over 13 that we're given here on the right-hand side. So if we're looking, right now we know that a squared is equal to b squared plus c squared, and we know that b is 12, so we know a squared is equal to 144 plus c squared. Well, we need to solve. We want to know what a squared is. Well, we can take our ratio that we're given, and we're going to rewrite that as c equals, so we can replace this, and we can solve for a squared. So if I multiply the a over, 5 over 13 is equal to c, and we're going to put that in right there. So we have a squared is equal to 144 plus 5 over 13, a being squared. And then we can solve for a from there. So we're looking, we have a squared is equal to 144 plus 25 over 169, a squared. So we'll get our numbers on the same side here to see what the constant is in front of the a squared. We get 144 over 169 a squared is equal to 144. And so we get a squared is equal to 169. And so a is 13, but we just need to know what a squared was to put all that back in to our equation. So our standard equation here would be x minus 3 squared over a squared, 169, plus y minus k squared, y minus 6 squared, over b squared, 144, is equal to 1. And we have our standard equation for that ellipse.